For millennia, we humans have gazed up at the night sky in wonder. We've told stories about the constellations, dreamt of reaching for the stars, and questioned our place in this vast and mysterious universe. Our ancestors could only imagine what lay beyond our world. But now, thanks to the relentless pursuit of science and exploration, we're uncovering secrets that boggle the mind. Today, we're about to embark on a journey to the edges of our cosmic understanding, to explore 10 mind-blowing space facts you probably didn't know. Fasten your seatbelts and prepare to have your perceptions of reality challenged as we delve into the awe-inspiring wonders of the cosmos. How do we even begin to comprehend the vastness of time itself? The answer is written in the faint afterglow of the Big Bang. About 13.8 billion years ago, our universe burst into existence. The Big Bang was an explosion of space itself, expanding our reality. We detect this event's echo as cosmic microwave background radiation. This radiation is like a baby picture of the cosmos. Analyzing it, we've concluded the universe is approximately 13.8 billion years old. Here on Earth, we're constantly bombarded by a symphony of sounds, from the gentle rustling of leaves to the roar of a jet engine. But in the vacuum of space, an eerie silence reigns. You see, sound, as we know it, is a vibration that travels through a medium, like air or water. These vibrations cause molecules to bump into each other, creating a wave of pressure that travels to our ears and is interpreted by our brains as sound. However, in the vast emptiness between stars and planets, there's simply not enough matter for sound waves to propagate. Space is a near-perfect vacuum devoid of the air molecules that carry sound. So if a spaceship were to explode in space, the event would be utterly silent, a cosmic light show without a soundtrack. It's a chilling thought, isn't it? To exist in a place where even the most cataclysmic events unfold in complete and utter silence. When we look up at the night sky, we see a seemingly infinite expanse of twinkling stars. But what if I told you that the stars we see are just a tiny fraction of what's actually out there? Astronomers estimate there are more stars in the universe than grains of sand on all Earth's beaches. And that's just the observable universe. The actual universe is likely much larger. Each twinkling point of light represents a distant sun, perhaps with its own planets. The scale of the universe is enough to make one feel incredibly small, yet connected to something greater. Now, you might think that the closest planet to the Sun, Mercury, would be the hottest. And it makes sense, right? After all, it's basking in the most intense heat and radiation from our star. But here's the catch: the hottest planet in our solar system is actually Venus, the second planet from the Sun. How is this possible? Well, it all comes down to the atmosphere, or rather the lack thereof. You see, Mercury has a very thin atmosphere, almost non-existent, which means that any heat it receives from the Sun quickly radiates back into space. Venus, on the other hand, is shrouded in a thick, toxic atmosphere composed primarily of carbon dioxide. This dense atmosphere traps heat, creating a runaway greenhouse effect where temperatures soar to an unbelievable 900 degrees Fahrenheit, hot enough to melt lead. So, while Mercury might be closer to the fire, it's Venus that feels the full brunt of the heat. Now, we've already established that Venus is a pretty extreme place, but buckle up because it gets even weirder. Imagine a planet where a day is actually longer than a year. That's right, on Venus, it takes longer for the planet to rotate once on its axis than it does to complete an orbit around the Sun. It's a mind-bending concept. But let me explain. Venus rotates incredibly slowly. In fact, it's the slowest rotating planet in our solar system. A single rotation takes a whopping 243 Earth days. Now, compare that to its orbital period, the time it takes to go around the Sun, which is a relatively brisk 225 Earth days. So, on Venus, you could celebrate your birthday every year, but you'd have to wait quite a while for sunrise and sunset. It's just another reminder that our solar system is full of strange and wonderful worlds, each with its own unique set of characteristics. Diamonds. Those sparkling symbols of love, luxury, and enduring strength are formed from carbon under immense pressure deep within the Earth's mantle. But what if I told you there might be an entire planet out there made of diamonds? It sounds like something out of science fiction, but the possibility is tantalizingly real. You see, in recent years, astronomers have discovered thousands of exoplanets, planets orbiting stars outside our solar system. And some of these exoplanets are thought to orbit the remnants of dead stars, known as pulsars. Pulsars are incredibly dense, rapidly spinning neutron stars that emit beams of radiation. Now here's where it gets interesting. Some scientists believe that certain types of pulsars, when they form, might leave behind a companion white dwarf star composed primarily of carbon. And if this white dwarf is subjected to enough gravitational pressure from the pulsar, it could theoretically crystallize, forming a giant diamond planet. Imagine the bling! Body space travel, the ultimate adventure, pushing the boundaries of human ingenuity and exploration. But venturing beyond Earth's embrace comes at a cost. You see, our bodies, finely tuned for life in Earth's gravity, undergo some strange and fascinating transformations in the weightlessness of space. One of the most noticeable effects is on an astronaut's height. Without the constant downward pull of gravity, the spine is free to elongate, causing astronauts to grow taller, sometimes by several inches. But don't get too excited. This height boost is temporary, disappearing upon their return to Earth's gravity. However, the changes don't stop there. Microgravity also affects muscle mass and bone density. Without the need to support their weight, astronauts' muscles can atrophy, and bones can weaken over time. That's why astronauts on long-duration missions need to exercise regularly to combat these effects. So, while space travel may seem glamorous, it's a testament to the adaptability of the human body, capable of enduring and even thriving in the most extreme environments. Black holes, those enigmatic cosmic monsters, lurking in the depths of space, warping the very fabric of space-time. They are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. Imagine, if you will, a star, many times more massive than our sun, collapsing under its own immense gravity. As it collapses, its density increases, and so does its gravitational pull. Eventually, the gravitational pull becomes so strong that not even light, the fastest thing in the universe, can escape its clutches. And thus, a black hole is born. But it's not just light that's affected. Black holes also warp time itself. You see, according to Einstein's theory of general relativity, gravity warps the fabric of space-time, and the stronger the gravity, the greater the warping. This means that time actually slows down as you get closer to a black hole. So if you were to observe a spaceship falling into a black hole, you'd see it gradually slow down and eventually freeze in time, trapped forever on the event horizon, the point of no return. In 1969, humanity achieved the impossible, setting foot on another celestial body. The Apollo 11 mission marked a pivotal moment in human history, and the images of Neil Armstrong's first steps on the lunar surface are forever etched in our collective memory. But did you know that those iconic footprints, along with the lunar rover tracks and other artifacts left behind by the Apollo missions, will likely remain undisturbed for millions of years? Unlike Earth, the moon has no atmosphere to speak of. This means there's no wind to erode the surface, no rain to wash away the footprints, and no geological activity to reshape the lunar landscape. The moon is a place frozen in time, a celestial time capsule preserving the legacy of those early explorers. So, barring any unforeseen cosmic events, those footprints will remain as a testament to human ingenuity, a permanent reminder of our first foray into the cosmos. Mars, the red planet, has long captivated our imaginations with its rusty hues, towering volcanoes, and the tantalizing possibility of ancient life. But this seemingly barren world is also home to some of the most extreme weather in our solar system, including dust storms of epic proportions. Imagine a dust storm so large it engulfs the entire planet, blotting out the sun and turning the Martian sky a hazy red. These dust storms, unlike anything we experience on Earth, can last for months, shrouding the planet in a cloak of dust. Now you might be wondering what causes these massive dust storms. Well, it's a combination of factors. Mars's thin atmosphere, combined with its low gravity and elliptical orbit, creates the perfect conditions for dust particles to be lifted high into the atmosphere. And once these particles get lofted, they can be carried by global wind patterns, creating planet-wide dust storms that can last for months. It's a testament to the raw power of nature, even on a seemingly desolate world like Mars. As we conclude our exploration of these mind-blowing space facts, It's important to remember that we've merely scratched the surface of cosmic understanding. The universe is vast, mysterious, and constantly revealing new wonders. Every new discovery, every image captured by our telescopes, every mission into the unknown deepens our appreciation for the intricate workings of the cosmos and our place within it. So keep looking up, keep asking questions, and never lose your sense of wonder. For the universe is full of secrets waiting to be unlocked, and it's up to us, the curious inhabitants of this pale blue dot, to unravel them.